Scripting for the Web, WS300, Platt College. Types of errors. Syntax. Typos fall into this category, but also when you have mismatched a method to a data type. For example, uppercase not working on a number data type. Runtime. You will only see this in a function that's not been called during the creation phase of the program's initialization. This can be a syntax error within that function, and it only gets caught when the program is running. Logic. When your program works, you get unexpected results. So syntax errors. Typos happen, like BTN versus BTM. An easy mistake and sometimes hard to catch since N and M look very similar. You can't really avoid stuff like that. My recommendation to help with the common syntax error messages are to work your code outside inward. That is, close your quote, curly bracket, parentheses, etc., and then go back inside and type what you need to type. A runtime error is an error that occurs during the running of the program, also known as exceptions. An example might be a function calling a different function that does not yet exist. When the code is called to execute that line of code, it will throw an error. Logic error. These are the hardest to track down, and this is why flowcharts are good to use to help work out the problem. What should it be doing versus what is it doing? That's important to know. Path errors. You should know by now paths are important. If the computer does not know where to find your file, it will not guess. It will just give up. It will give you a 404 and it'll go, I got nothing. The source property works like a link's href. If we click on a bad link, what happens? We go to the wrong page. If that page is missing, we get a 404 error. Its job is to define a path to a specific file. This works for images too, if you recall. If the source property is wrong, then it will, in essence, give you the wrong item or serve up a 404 resource not found error. Best ways to check this is with the Network tab in your browser's development tools. You can see here a diagram of a folder and document structure, defining paths and tips. Think of this as specifying a URL for the resource you need to add. URL stands for Uniform Resource Locator. This is why I'm always asking, where does it think the file is located? You'll often hear that interchanged with URI, which is Uniform Resource Identifiers. A URL is a specific type of URI. All URIs are a means to access a resource on the internet and are a technical shorthand used to link to the resource. URIs always designate a method to access the resource and designate the specific resource to be accessed. Absolute path is like a postal address. It contains all the information for any web browser anywhere in the world to locate the file. It includes HTTP, the host name, the folder, and the name of the file. If you are linking to a resource beyond your site or local folders, you must have an absolute path. An example of this would be using a jQuery CDN, located on Google or jQuery or someplace else. Root relative path indicates where a file is located in relation to the site's top folder. Here you can see the root folder. An easy way to make a root relative path is to strip off the HTTP and the site name from an absolute path. A document relative path specifies the path from the page to the file that you need. For example, the about.html file is in a pages folder. In order for it to access the site_js.js file, it needs to do the following: /libs site_sj.js. Tells the about that the path needs to climb out of the pages folder, go back to the root, then go into the libs folder, then find the site_js.js file within. Further complications. What happens when you define a path in your external JavaScript file? Because the page calling the JavaScript file acts like the JavaScript file is part of the page, the JS might as well be in the same directory as page.html. The path calling the image and displaying it with the JavaScript would be different for the page.html versus about.html. A few solutions for this. 1. Keep all your pages in the same directory. That would be my personal favorite. 2. Write document relative paths. Also, what I recommend. 3. Have the appropriate relative path in the data/HTML page itself. We can do this with a data-attribute, internal versus external, which to use. External JavaScript files is what you will see the majority of the time. It looks nicer, it separates the HTML from the JavaScript, and makes it a bit easier to see the programming versus the structure. It is also good when multiple pages need to link to the same script to use its functionality, such as we see in a website. Internal JavaScript in a single script tag is good in order to focus on the functionality within a specific page that you don't need to have access to on other pages. It loads faster and only on the page in which it is needed. This cuts down bloat. CDNs are good for libraries, which are often external files. Since a server can only download 2 files to the same IP address, a lot of larger companies use what is called content offloading for images and videos. Examples of this would be embedded YouTube videos or even the slideshow on my website hosted in my Google Drive.
Tips for better programming. Think top-down design. When I say think top-down design, I mean think of the overall goal and break that down into the steps you need to take to get to that goal. Break it down into the little pieces like we did with the flowchart examples in class. Use flowcharts to help you visualize the process. Every time you put a step onto your flowchart, ask yourself if you need to break up that chunk into an even smaller chunk. Using variables allows us to keep track of values and reuse those same values in multiple places. Thus far, we've seen variables used to store an element from the DOM so that we can manipulate its properties over and over and over again. In the moveDiv example, we've seen it also store a property's value and then use that variable to manipulate that object's properties. Also, using functions to be able to call and recall the code upon demand, using it when we need it. DRY stands for don't repeat yourself, so try to keep dry in mind when writing code. If you find yourself writing code that is the same or very similar, consider putting that code into a function so that you can use it in multiple locations but only have to write it once. You will see examples of this in class.
Tips to reduce errors. Write the complete structure of the if statement and then go back to insert the conditional information inside the parentheses. Write the full structure of the function or switch or loop or whatever code construct you are working on. Then fill in the details. Sublime Text will often give you this structure. Writing in pseudocode means trying to say what you are trying to do in plain English. If you can do this, you are well on your way to figuring out what it is that you need to do. For the same reason you measure twice and cut once, flowcharts help you work out the logic in advance. Build small, test frequently. If you write 15 things and your code breaks, it will be hard to figure out which item is not working. Once something works, set it aside. That way you can go back to it later and save yourself some headache if the stuff you've added to it or changed made it stop working and your original code is now unrecognizable.
Make sure to comment your code. This will help you keep focused on the intent of what you are doing. Commenting with pseudocode, for example, helps you keep focused on your goal, and while you write your code, it will help you understand what is happening in your code if you need to look at it again in a few months. Think of comments as little post-it note reminders.
Debugging. Debugging is the process of testing, finding, and reducing bugs or errors in computer programs. The first known computer bug was a real bug, an insect that was stuck in the electronics. This is where the term originated. Tools for debugging. The console, the rubber duck, and flowcharts. I love the console. You can write code to be sent to the console, and it's like your little secret. It's a quick and easy way to see what is the value of a variable when a conditional is checking against it, what is the object that I've gotten a hold of. It tells us all kinds of nifty information without having to alert. It helps you figure out what's going on. The rubber duck. The idea here is that if you can explain the problem in simple terms, verbalizing it can help you hear it and figure it out as you are bringing more and different parts of your brain to bear on the problem and thinking about it in a different kind of way. Many programmers have had the experience of explaining a programming problem to somebody else, possibly even to someone who knows nothing about programming, and then hitting upon the solution in the process of explaining the problem. In describing what the code is supposed to do and observing what it actually does, any incongruity between these two becomes apparent. More generally, teaching a subject forces its evaluation from a different perspective and can provide deeper understanding. By using an inanimate object, the programmer can try to accomplish this without having to interrupt anyone else. Sometimes just formulating the question properly yields the answer that you need. I don't know how many times this has happened. I have a problem. I decide to take it to Stack Overflow. I awkwardly write down my question. I realize that the question doesn't make any sense. I take 15 minutes to rethink how to ask my question. I realize that I'm attacking the problem from the wrong direction entirely. I start from scratch. I find my solution quickly. Does this happen to you? Sometimes asking the right question seems like half the problem. Beginning to ask a question actually helps me debug my problem myself, especially when trying to formulate a coherent and detailed enough question body in order to get decent answers. The critical part of the rubber duck is to totally commit to asking a thorough, detailed question of this imaginary person or inanimate object, even if in the middle of asking a question you realize you made a dumb mistake. The great thing about using a rubber duck is that it doesn't take up someone else's time. The rubber duck doesn't judge you, and it's very patient as you work through the issues. Write it out in a flowchart. This helps us visualize the process. Here is a problem. Can you spot it? How many hours of the day are 0 or greater? All of them. This needs to be changed so that the conditions appear from the rarest to the most common.
And a flowchart can help you see that process and where it has gone wrong. Summary. Remember the 3 types of errors. Most often, especially in the early stages of your programming career, you will run into syntax errors. Typos are the bane of our existence. Logic errors are the most difficult and troublesome of errors, as it is an error in your way of thinking. Use the flowchart and the trace method I mentioned in class, and though it seems silly, use the rubber duck. Commenting and pseudocode are helpful in their own ways, and always try to think of the project from the top down, keeping in mind that end goal, and then breaking it down into smaller pieces and smaller pieces until they become manageable. I hope this has been helpful and informative, and as always, happy coding!